In this video, I'll be introducing Mathematica, assuming no previous knowledge with that software. And what we'll be doing in Mathematica is building a virtual set deck for us to study. So let's begin by opening up Mathematica. I've got a little icon down here, or else you could click on the icon on your desktop. And you're going to create a new Mathematica document and open it up. Now, the very first thing that we ought to do in a Mathematica notebook, as it's called, is do a very, very simple computation. So I always just do 1 plus 1. And note that if I hit enter, nothing happens. My cursor just moves down the screen. But if I return to my computation and hold shift while I hit enter, it actually evaluates that cell. Now notice that it took a second to compute quite a simple calculation, 1 plus 1. The reason it does this is because it's loading a lot of functions that you might be interested in using in the background. And so that process of loading all of those functions and knowledge into the computer is what takes so long, not the actual computation. But that is the reason that we often do a simple calculation on the first computation, just to give the computer that time to load without overwhelming it with a difficult computation to do as well. Now, the next thing that we should know about Mathematica is that we can do computations like we just did within Mathematica, or we can write text, which is helpful for explaining the things that we're doing within Mathematica. So that's a practice I'll be engaging with today. If you want to switch where your input is into a text format, one thing you can do is hit Format, Style, and go straight to text. But it also shows you that there's a keyboard shortcut to that, which is holding Alt and pressing the number 7 on your keypad. So that shortcut is typically what I do to switch from input to text. Come up to the top with my cursor, hold Alt, hit 7, and type in Mathematica. We often start with a simple computation to load Mathematica's libraries. Now, the very first thing that we're going to want to use Mathematica for is to build a representation of our set deck. The way we're going to represent each individual set card is as something of a 4-tuple. Remember that a set card has 4 different attributes: a color, a shape, a number, and a fill. So we'll associate each one of those attributes with a component of an ordered 4-tuple, thinking of perhaps the first component as the color, the second component as the shape, the third component as the number, and the fourth component as the fill. And then for each of those 4 attributes, there are 3 possibilities for that attribute. So what we'll be doing is we'll be using the numbers 0, 1, and 2 to represent those 3 possibilities for that attribute. Our goal right now will be to create a set deck, and we essentially want to build all 81 cards out of those 81 possible combinations. In order to do that in Mathematica, we're going to use a list that is built out of a table. So the table function in Mathematica is one of the absolute key functions that we'll be using over and over again. And in many ways, it's equivalent to a for loop if you've seen that in a different kind of programming language. But before we get to using a table, I think it's really important in Mathematica to understand how to ask for help. So in order to ask for help in Mathematica, you can first type a question mark and then the name of the function that you're interested in, and this will initiate a little drop-down menu that shows you what some of your options are. Since we're interested in table, we can select that from the drop-down menu, hit Shift-Enter, and a little help manual pops up. Now what's shown here is a short version of the help function, and it's trying to show you the syntax of Mathematica. And syntax is the rules of a programming language. In Mathematica, for example, one such rule that we will get used to is that all functions and all new words in a function's name will begin with a capital letter, with subsequent letters being lowercase, and arguments are passed to functions via square brackets. This is because round brackets are a symbol that are ambiguous for mathematicians. When we combine mathematics with a programming language, In mathematics, we often use parentheses to indicate groupings or order of operations, but computer scientists frequently use parentheses for passing variables to a function. So to clarify which we mean in a mathematical programming language, we simply use different symbols. So parentheses will be reserved in Mathematica for that mathematical grouping of order of operations, and square brackets will be used to pass arguments to functions. So those are things that we can see in this short little help menu that we have right here. Now, once you're familiar with Mathematica, or you're somewhat familiar with interacting with software like this, maybe this short help menu is enough for you to understand what's going on with the table function, and maybe it's not. And so this little I that's right up here is for more information on the table function, and should we click on it, a separate window shows up, again showing us that shorthand that appeared within the Mathematica notebook, but also with the opportunity to see examples and details of the function. So if we need to see some examples of what we could do with the various formats of this table function, we're able to see that by scrolling through this more in-depth help manual. And at the bottom, it also gives us some suggestions for other functions we might be interested in, or an opportunity to see tutorials on various things that we might want to do with the table option. So knowing how to get help in Mathematica is really useful because Mathematica can be a difficult piece of software to gain familiarity with. So let's close out of our help manual for a minute. And let's imagine that we wish to use this table function within Mathematica to build a 2-feature set deck. That is, we want to build that 9-card set deck, which here will be represented by 9 ordered pairs, where 0, 1, and 2 are the options for the first component, and 0, 1, and 2 are the options for the second component, with all possible combinations of those things. Following the format provided for us here in this help expression, we want to create a table that is a combination of 2-lettered values, I followed by J. I'll return to talk about those squiggly braces in a moment. First, let's get the syntax of the table function down. In terms of this I, J that we have right here, that's matching up with this expression that we see for each of the table functions. This is what we want to make a table of, combinations of matches between I and J. I then put a comma because the table function needs more information. And what it needs is information about these letters I've introduced, I and J. Now you might notice a couple of things going on with the colors in Mathematica. The colors are there to try to help you. When Mathematica recognizes a word, expression, or variable name, it highlights that word in this bold-faced black, like you see for table. So the fact that this is occurring in black means that Mathematica recognizes this and knows the definition of this word table, this function. If you look closely at I and J, however, those are a dark blue color. And this dark blue is indicating that Mathematica does not know the definition of those things. And the red is what most programming interfaces will use to indicate that there's some sort of problem. So right now, I've got a little red comma and a red caret marker indicating that there's a problem with the way I've currently formatted the table function and that I'm missing something in this particular location. What I'm missing is the next piece of information the table function needs, which has to do with the introduction of my I and my J. What are they, and what possible values should I put there? So that's what comes next. We're beginning following this format of the table function, where I've now wanted to introduce a variable, an iterator, I. We can see from the syntax provided there, I need those squiggly braces around I. Following the I need to put a comma, and I need to put a minimum potential value for I and a maximum potential value for I. So we've indicated that we want our I to go from 0 to 2. And now we can see that colors have changed, and I've eliminated the red that was in the function. Now my I variable, which I've introduced right here, has changed to a lighter blue color. indicating that Mathematica understands that I is a local variable. We're still not done at this point, only because J hasn't been introduced. So right now, J is still that dark blue color because my table does not know what the letter J means. So it's my job to tell it what is J and what are the possible lowest and highest values that J can experience. For me, J is really just the same as I. So I want to repeat that exact syntax with J, adding a comma, open and close braces, and indicating that the letter J should also take on the values between 0 and 2. Now everything in this expression is either black, meaning that Mathematica knows that word or command, or that light blue color, indicating that it understands this is a local variable. And if I hold Shift while pressing Enter, I see a lot of squiggles, followed by 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, and 2, 0, 2, 1, 2, 2. So this is a representation of my set deck.